So we're going to read Heating and AC Test 3. These questions come out of the Heating and Automotive Heating and AC textbook. And, you know, we kind of go over these during the semester, and then at the end of the semester, you're doing this open book test. It's one of those tests where nobody has any of the same questions on their test, and you pretty much got to, you know, hack around in the book and find the answers and all that, and you learn a lot that way. That's pretty smooth. Okay, so let's start out with this first question here. A vehicle's HVAC system contains a what? A, heater, B, air distribution, C, AC, or D, all of these? All of them. That's not complicated. You know, you got air distribution, your fans, your ducts, your doors, and all that stuff. And you got your air conditioning. And also, what else does the air conditioning do besides cooling the air on the inside of the car? What else does it do to that air?
Oh, just
it dehumidifies. It dries it out. And dry air is a lot more comfortable to us than wet air, typically. You know, air conditioning systems control which of the following in a vehicle? A, temperature, B, air cleanliness, C, humidity, or D, all of these. That's another D. You know, basically, the cabin air filters are not present on all vehicles, but that cabin air filter usually stops anything that's got 25 micron or bigger. You know what a micron is? Anybody know what a micron is in here?
I don't know the definition of
That's
what it is.
a millionth of a meter. That's a little tiny piece of, they actually have these little tiny white balls. It's like a millionth of a meter, and they see how many of them will go through a filter at a certain flow rate or something. I read that somewhere a long time ago. But it's a millionth of a meter. If you take a meter, it's like a thousandth of a millimeter, basically is what it is. So keep that in mind. If you know what, if somebody asks you what a micron is, you better be able to tell them that it's a thousandth of a millimeter. Two technicians are discussing heat movement. Technician A says heat's a form of energy. Technician B says heat travels from hot to cold. Who's right about that?
Both.
Heat is a form of energy, and heat does travel from hot to cold. Cold is not what travel, heat does. All right, so, and then, now, remember, let me back up for this other question. I got sidetracked. The cleaning of the air, somewhat, even on the ones that don't have a cabin air filter, this moisture that's on the evaporator is going to catch dust and stuff, you know, and it's going to wash out of there for the most part. So it's going to clean the air somewhat, but the cabin air filter even does a better job, and it cleans the pollen and the dust out of the air when you're on norm. Now here's a little bit of a trivia question. If I'm driving my whatever kind of vehicle it is I'm driving, you know the difference between max and norm on your air conditioner settings?
I do.
What is it?
You told us AC is norm, right? And MAX is
Yeah, but what's the difference though? What's changed
The-
between max and normal?
how much freon is going?
Not
It's
really.
colder on max.
Where you're getting the air from. If it's on max, you're re-air conditioning the air that's inside. If it's on norm, you're getting air from outside. All right, now let's say I'm driving from here to Atlanta, and I'm running my air conditioner on norm going to Atlanta. Temperature is the same, it hadn't changed. And I drive back from Atlanta with it on max. Now, what's going to give me the best gas mileage?
Max.
Max, why?
Something out there, and the thing engages and it spins and something about.
The compressor is not turned on as much
Yeah.
because you're re-air conditioning the same air. And so the compressor will cycle off more when the air is colder because it's based on pressure typically, or evaporator temperature. You see what I'm saying? So if your evaporator temperature is consistently lower, then your pressure is going to be lower, and your air conditioner compressor clutch is going to cycle off. When it's not cycled on, it's not burning as much gas. Now, a friend of mine tried that. Him and his wife went to Atlanta and back, and he said he got about 3 more miles to the gallon on max than he did on norm, which is pretty interesting, you know, and when you think about it, it makes sense. But a lot of times, since you feel like I've got my maximum cooling, I'm burning more gas. Well, that's not typically the way it is on these things. Once again, this is a principle, not a precept. A precept is a law that's always the same. A principle is if you do this, you can generally expect that.
So air conditioners do burn gas.
Yeah, the compressor's putting the load on the engine. Yeah. Okay, 2 technicians are discussing heat movement. We've already done that one. Both of them are right. That's going to be a C. Heat intensity refers to which of the following? A, the heat individuals feel. B, the number of BTU in an area. C, the amount of heat in an area. Or D, none of these.
B. Wait, no.
This is people that are engineering air conditioning systems. That's actually going to be A. That's the heat individuals feel, how much heat you feel. Did you know some of these vehicles have got a sun load sensor that will change the air conditioner strategy if the sun's hitting the dash in a certain way? And they've actually got some of your Asian cars that I know about, that when I went to the MAX convention, they talked about have got humidity sensors so that they can tell what the humidity and the air barometric pressure is and all that. I mean, they calculate all that so they'll know how to evaporate. The freezing point of water is what? On the Celsius scale.
0 degrees.
It's 0 degrees on the Celsius scale. See, the Celsius people, well, they wanted to make everything in metric people. They want to do everything in divisions of 10, so they have 0 at freezing and 100 at boiling. A boiling point of water is 100 degrees on the Fahrenheit scale, right or wrong? What is it?
212.
212, that's right. It's 212 on the Fahrenheit scale. It's 100 on the Celsius scale, though. Number 7, Technician A says 1 C of heat can increase temperature of 1 G of water by 1 degree F. Technician B says the temperature will increase 1 C if 1 C is added.
1 degree Fahrenheit, 1 degree Celsius.
Incidentally, let me back up to question number 4. What does BTU stand for?
British thermal unit.
And what is a British thermal unit? How would you define a British thermal unit?
That's a good question.
A couple of ways you can define it.
I know the
Is it
BTU
like
air conditioners, that's all I know.
The capacity for heat in a certain...
Sort of, but the easiest way to define it is it raises the temperature of 1 pound of water 1 degree Fahrenheit. That's how much heat it takes to raise the, like a pound. How much is a pound of water?
A pound of water, 16 ounces.
16 ounces a pound of water. And if you applied enough heat to that pound of water to raise that pound of water 1 degree Fahrenheit in temperature, that's 1 British thermal unit. It's about like striking a match. If you strike a regular match, that's about a British thermal unit right there. And all that. So, and a match ain't gonna burn long before it burns your finger, So that's give you a pretty good little idea about what a British thermal unit is. Okay, but anyway, number 7, the answer to number 7 is B. Technician B says the temperature will increase 1 degree Celsius if 1 C is added. Little heat measurement thing.
What's 1 C in this case?
That is a sort of, it's kind of like the way I understand it, correct me if I'm wrong, somebody might say, you're a dummy, you don't know what you're talking about. That's like the British thermal unit of metrics. You get me? You get where I'm going? It's kind of like, it's actually it's the measure of heat, but it's metric instead of British. British is imperial. The British do inches and feet like we do. Like if you work on a Perkins diesel engine that's made in England, you're going to reach for a 9/16 and a half inch. You're not going to use metric tools. You would think you would, but England is where we got our inches and feet. You got me? So that's like basically that little C is kind of like a British thermal unit, except it's metric. The normal temperature for an average human is what? 98.6. Unless you're a human torch or something, then you'll be really hot. The amount of moisture contained by air is called what? Humidity. That's not too complicated. Let me ask you this. What does it mean when you look at the weather and it says the dew point is 61 degrees? What's that telling you? What happens when the dew point and the temperature come together? If you look at your dew point on your weather channel and it says the dew point 61 degrees and you look at the thermometer and it's right close to 61 degrees, what do you have outside? Huh? You have fog.
Fog.
You have fog.
Dew point is the
Foggiest one?
If the dew point and the temperature come together, you get fog. That's basically the way that works. In addition to cooling the passenger compartment, an air conditioning system does what? What does it do?
Dehumidifies air.
Dehumidifies air. That's a good answer. Number 11. What's the purpose of air conditioning? We're hammering on this to make sure you guys are saturated with it. What you got? That's all of the above, isn't it? The main source of heat used to warm the passenger compartment is what? What do you warm the passenger compartment with? Yeah, you're going to basically use the vehicle engine to do that. Now, on some of these hybrid vehicles, since the engine's not running part of the time, you got to have supplementary heat sources or ways to store the heat so that it can be recycled. You got me? You understand what I'm saying? Make sense?
Don't those batteries produce a lot of heat as well?
No, the batteries actually need to be cool. You got to keep those batteries cool. That's why, if you remember,
Don't they produce heat in some way though?
they do. Yeah, they produce heat, but they don't use that to heat the car because it's not reliable. It's not predictable. But the hybrid batteries operate better when they're a little bit cooler. Now, they don't need to be cold, but they need to be pretty cool most of the time. How many of you guys have ever had a dead battery, though? And this is what confuses people about the temperature of batteries. If you got a dead battery and you're wanting to use that battery for just a minute, you can heat that thing up. You get it good and hot and plug it in, that battery will have some power coming out of it, even if it was dead before you heated it up, until it cools off. And then that power goes away. So, but in the hybrid batteries, or a lot of them are either lithium ion or nickel metal hydride, and they're stacked together like, imagine you know how, if you've got how much battery power is in a flashlight battery? How many volts?
6.
In a flashlight battery?
I don't know.
1.5. If you stack them together, positive to negative, in series, it's going to multiply. Like if you got 2, it's 3. If it's got 4 and a half and 6, it goes up.
Mine's super flashlight's got 2.
Yeah. Well, no, it's got 3.
Okay.
It's got 3 batteries in
I
it.
can tell you something. My remote, my radio in my car, it wasn't working, so I put it on the heater, and it got real hot, and it started working again.
Yeah, it started working again. Yeah, that's what I'm saying. You do that.
I knew the battery was high, so I was like, well, if I put it on the heater, it'll start working.
Is it true that, like them, what are they, 3 or 6 volt little square things?
The 9 volts. No.
They're about that big?
Oh yeah.
What is it, a 6 or a 3?
Well, the 6-volt battery is the lantern battery. Yeah.
Is it true that that's full of double A's?
Yeah, I wouldn't be surprised. They stack that thing full, and what they do is they put them in there so you still come out with 6 volts. But even on a 9-volt battery, a 9-volt transistor battery, if you take it apart, it's got 6 little batteries in it that are wired in series. See what I mean? And these hybrid vehicle batteries are a whole bunch of batteries in series. They're what they are. You keep adding them to it, you can get lots and lots of voltage out of a battery. If I got 1,000 flashlight batteries and I stacked them together, the right way, I could get 1,500 volts out of 1,000 flashlight batteries. And that's pretty stiff. If you got enough flashlight batteries and stacked them together, you can start your car with it. So you just keep adding on there. It'll go to town. You got to. You got to have a good strong hookup. And all that. I mean, there's a lot of points where you can have bad connections there too. So you got to have good solid connections. But anyway, we're going to take this battery apart. I got a hybrid battery out of a Toyota out here. It's pretty interesting. We're going to pull it apart later this week if we can get it up on the table and look and see how it's put together. And I'm going to show you guys some stuff about that hybrid battery. But anyway, the 3 states of matter are what? Okay, that's solid, liquid, and vapor. It sounds pretty good. Okay, what is at what point does a solid turn into a vapor? The boiling point. Okay, what is the boiling point of steel?
Boiling point of steel?
Yeah.
Oh, that's probably like a lot.
Like 3,000 degrees or something like that, yeah. All right, technician A says the freezing point of a substance is the temperature at which a substance changes state from a solid to a liquid. Is that right? No. Technician B says the freezing point of a substance is the temperature at which a substance changes state from a liquid to a solid.
Yes.
All right. That's the freezing point. And so the freezing point of some stuff is really up high. See, if you let a piece of steel cool down from when it was really, really liquid, and it turns into, it still can be blistering hot and reach its freezing point, you see. But the property of solids will change with temperature a lot. Remember what I was talking about last week? If you go to Siberia in the wintertime when it's 60 below zero and you drop a wrench on the concrete, it's going to shatter like a piece of glass. And you've ruined your snap-on wrench. You know what I mean? So you got to be particular about that. And
Yeah, on rooms.
all kinds of stuff
Hey,
happens
the
with
rooms
temperature.
Snap on rooms, they got lifetime warranty, right? You just call them when you're doing it, right?
Unless they found out you used it on an impact wrench, and then sometimes they won't give you another one.
Oh,
also.
man, yeah.
They'll say, use this wrench on an impact wrench.
Yeah, but how
I've
about-
actually had them do that. I mean, I actually had a four-wheel drive socket one time that, you take off four-wheel drive, and everybody had used it on an impact wrench. And so I go to trade it in because one of the little ears broke off. It was a snap-on. He goes, no, that's not guaranteed. Used it on an impact wrench. And so he put it in his little bin down here, going to trade it in, get him a freebie, and he wanted me to pay him $32 for one that was made out of malleable steel. So it depends on the snap-on man and what kind of mood he's in, really, with all due respect to snap-on. And, I think that guy was trying to put the hoodoo on me, though. I don't think that snap-on would have probably guaranteed it for sure.
So what was 14?
14 was basically going to be the what did y'all tell him, guys? B, wasn't it? B or what? Technician B only, yeah. The measurement of the actual weight of water in a given volume of air is what? What would you call that? The measurement of the actual weight of water in a given volume of air is blank.
Absolute pressure?
No.
Relative humidity?
Relative humidity, that's right. The relative humidity is the... All right. So you got that. All right. Now, remember what I said earlier? I was telling Willie this earlier. 16 ounces of water weighs 16 ounces of weight. That's where they come together. And a cubic centimeter of water weighs a gram. And so 1,000 cubic centimeters weighs a kilogram. So a kilogram is a liter of water. A liter of water weighs a kilogram, right? If you throw a washer and you hit his glasses, it'll break. Me and this boy was playing this basketball game where you throw coins and try to catch it. The first time I threw that nickel, it went, broke his glasses, That was in elementary school, but he was not happy. I didn't do it on purpose. All right. So, amount of water that air can hold depends on what?
Absolute pressure and temperature?
No, actually, it's the air temperature. The hotter the air is, the less it's going to hold, basically. And number 17, 1 British thermal unit is equal to how many calories?
I'm going to jump out there and say 32.
What about 252?
Is that it?
Yeah, 252 calories. Now, what does that mean? Do you remember there was this survival story about this man and his wife and the little baby that was in the mountains on a plane crash, and she was eating snow because she felt like she would need the moisture to milk the baby, and she died, and they didn't, because her body used all of those BTUs melting that ice she was eating, and she froze to death. Well, they didn't, because they didn't eat that ice. See what I'm saying? So the calories, the coldness that you get when your body has to process something and warm it up, it's burning calories. And that's why in the wintertime, if you're out there in the wintertime a lot, like in these people that work in these Arctic stations up there where it's really, really cold, they have to eat a heck of a lot of rich stuff to keep calories in them so that they can stay warm. You know what I'm saying? Have a skinny guy like Jeremy, he would freeze up there. See what I'm saying? But a fat guy like me and Willie, we would do just fine. Is that right with it? All right, so, all right, now we, yes. All right,
Hey,
now let me see.
why do you have a moment? Is 15 C or D?
Huh? 15? What do you think, guys? What was it? C?
C.
Yeah.
C. See what I say?
Relative humidity. That's what Daniel was saying a while ago. Which is the following is true about heat?
Cold is lack of
And?
is a form of humidity.
All these.
And heat always travels from something warm to something cold.
Oh, okay.
All of the above. Look at here. A burning kitchen match
252.
gives off how many calories?
252.
Make sure you understand that. Let me ask you this. How many British thermal units does it take to turn 1 pound of water totally into vapor?
3. Wait,
212.
We're taking a pound of water, we're going to totally turn it into vapor. We're going to have to add a certain amount of BTUs to it.
we're gonna add. We're going negative or positive here?
5 of them.
If you're going negative, you're going to be freezing the water, not turning it into vapor.
Oh yeah.
Somebody smartphone that for me. Excuse me. I got hiccups. How many BTUs of water does it take to turn 1 pound of heat? Does it take to turn 1 pound of water completely into vapor?
Can you say that again when I put the speakerphone through the TV?
How many BTUs of heat does it take to turn 1 pound of water totally into vapor? Give me that number.
BTUs, you said it takes to boil?
No, it turned it totally into vapor. I want that pint of water to completely boil away into steam. How many PTUs do you got to add to it if it's water? Okay, number 20. Many late model vehicles, incidentally, is 252 and 19 is A. And number 20, many late model vehicles use what to help clean the air? Cabin air filter. Those first appeared on the 95 Ford Contour. That may be a trivia question one day. All right. Test 4. Everybody's got a copy of Heat and AC Test 4. And I do apologize for the hiccups. You'll just have to put up with those because I can't make them go away. They'll go away by themselves, but I can't make them go away. And I don't have them all the time. They're not chronic. They're just... I went through that whole first test and didn't get hiccups till question 19. Okay. Which of the following is true about heat? All of these are true. Cold is the lack of heat. We went through this before. Number 2. What occurs when heat travels through a material from one molecule to the one next to it?
Conduction.
Yes, it gets conducted. Okay, the process of transferring heat by circulating the heated media is called what?
Convection. Oh, yeah, okay.
What is it?
Radiation.
No, you said
Number 2?
Heated media.
it.
I mean, number 3, I'm sorry.
Convection, see?
Convection. It's conveyed. You got me?
Doesn't the convection oven use the air?
Yeah. It conveys the heat with the air. You're actually not radiating the heat. You got hot air blowing on it, and that's what's cooking it. Well, you were pretty close. The movement of heat through heat rays is called what?
Radiation.
Radiation. So when you're out in the sun, or if you're under one of these blistering hot infrared heaters, you're going to have that too. Molecules are composed of what? Atoms. Now this is an interesting little factoid. If I brought the nucleus of an atom up to the size of a baseball, did you know the nearest electron ring would be like 2 or 3 miles away? Atoms are mostly empty space. We're made of atoms. The counter is too, so we're interacting that way. But there's more empty space in an atom than there is solid stuff. Remember that. Okay. Which of the following is a form of matter?
All of these.
All right. Which describes sensible heat? That's a good question, isn't it? Sensible heat.
What do they mean by sensible heat?
Heat that you can sense. No, not all of them.
Because it causes
Big temperature change.
It causes the temperature change. Now, it won't necessarily cause a change of state, and it won't necessarily cause a liquid to boil. Now, why do you think they call it sensible heat? As soon as you can feel it, starting to change the temperature.
See, why does it have to be only your sense of feel? You see it change from one state to another.
Well, you can, but it's a sliding scale. Which measurement is it though that you're actually looking at? You can actually, if you can feel it, it's sensible. See what I'm saying? Now you're obviously going to feel those other ones, but they are sensible heat is here, and the heat you're talking about is way here.
See, I can see that.
Yeah, you can.
Sight is a sense.
Yeah.
I didn't want to say that.
Yeah. Well, if you see me start fanning, you know I'm hot.
See, I'm just being facetious.
Yeah. That's all right. Okay, blank causes a change in a state of matter. What do you think about that one? What is it? What kind of heat? You guys over there, what kind of heat is it that causes change in a state of matter?
B. What does B mean?
Latent heat. The latent heat. You got two different types of heat.
You just said sensible heat doesn't change state, so.
Actually, latent heat does cause a change in a state of matter. Not sensible heat, latent heat. Latent heat, like whenever, you remember I was talking about when the refrigerant is changing from a liquid to a gas, it's absorbing heat. When it's changing from a gas back to a liquid, it's giving off heat. Those are the two kinds of latent heat. You have the latent heat of vaporization and the latent heat of condensation. And where does vaporization take place in the AC system?
Evaporator.
The evaporator, that's right. And condensation takes place in the condenser, doesn't it? Okay. Whoa, look at here. Did somebody ever find this answer? It takes how many BTUs of heat?
It takes 144 BTUs.
Boom.
How many BTUs of heat to cause a change from the state from 1 pound of water to 1 pound of steam?
We're not to that question yet.
Mm-hmm.
I didn't get that.
I asked you that earlier.
970. What's wrong there?
970 is right. That is a lot of BTUs. Remember that? Now, what did I say earlier? I said it takes one BTU raises the temperature of a.
Oh, no, that's ice to water.
Huh?
Okay,
That's changing it from ice to water,
Yeah,
isn't it? Yeah, 144 is what changed. That, I knew that was a good number, but it wasn't what we were asking.
So the BTUs on an air conditioning unit, is that its capacity to remove?
Hey, a good one. A good
To remove heat from a
about
particular
50,000
size.
BTU.
Now, I will tell you this: the car air conditioners, as far as from our perspective, are not rated. Let me ask you that, Daniel, since you work at Lowe's. Why do they rate house air conditioners in BTUs, but they don't rate car air conditioners that way? Think of a reason.
Well, it's not.
Zach, what do you think?
I think.
They don't rate car air conditioners. Like if you go to buy a car air conditioner, they don't say anything about no BTUs, do they?
Answer's
No,
B.
but it
But-
won't be able to produce enough BTUs like.
Well, it has to produce enough to keep the car cool, but basically, you can buy any size air conditioner for your house that you want. You just have to determine what size unit
Square feet
you need. You know what I'm saying? But on the car, if you're going to get air conditioning, you're going to get something that's made to fit that car, and it's, you know, you're not going to get a bigger or a smaller air conditioner for the car. They're all going to be the same size for that car. They're just not rated that way. They are rated in BTUs, but you don't buy them that way. You see what I'm saying? And most of the time, cars have air conditioners on them now anyway, unless somebody lives in Ohio or somewhere where it don't ever get all that hot. A lot of times they'll just roll the window down up there. I bought a pickup one time that was sold up there initially. It didn't have no air on it. All right. Let's see. The boiling point of a liquid can be increased by raising the what?
B.
Pressure.
B.
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 A.
No, not A.
You can raise the pressure. You can also, like if it's water, you can pour antifreeze in it, or, you know. But if you pressurize it, it's going to raise it. What is the boiling point of water at sea level in Fahrenheit?
All I know is boiling point of water is 212.
Okay, what is it in Denver, Colorado?
212.
No. You put it on you put a thermometer in a boiler of water up there, it's going to boil at about 160 degrees. Why is that? Somebody tell me.
Less pressure.
Huh?
Less pressure.
Less air pressure, that's right. Okay, so what happens if you pull all the air out of a closed chamber that's got water in it?
Ignition.
the water is going to just turn into steam because it's pressure that keeps the water together. If you squirt water, like if you could figure out a way to do it, if you could squirt water out into space, it would be instant vapor.
So is that the concept by which a diesel works?
Of what?
A diesel?
Well, the diesel actually,
Under pressure and everything?
well, no, the pressure is hot. The diesel engine is going to light off because when you squeeze the air, you're going to get 2 pounds Fahrenheit for each pound of pressure, and you got 1,000 degree air, and you miss that fuel in there, it's going to explode, and that's what makes a diesel run. But it's not, I mean, the pressure and the temperature are related. Superheat refers to temperature increases in vapor after the liquid is boiled. True or false? Let's say that you're in a chamber and you've boiled that liquid in spite of the fact that you're under pressure. As that steam gets hotter and hotter in that pressurized chamber, that's superheat. Got me? Okay, now this is an interesting question here. 0 psi-G is what? You're going to see this. I want you to know what it is. 0 psi-G. What in the world is that? We know what psi is, right? What's that? Okay, so what in the Sam Hill is psi-G? Because it's obviously something different, or they wouldn't put a different letter on the end of it, or an additional letter, huh?
0.1 gauges.
It's equal to 50, hiccups galore. It's equal to about 15 psi on the absolute pressure scale. You got it? Now look at that. Now watch. Why do we say that? About 15 psi. What is about 15 psi? Why are we talking about that? Why would we even put that on there? 15 psi is what? What's it close to? We talked about it last week.
What, 14.8?
14.5 psi is the air pressure at sea level.
Yeah.
Okay, so right now, from our perspective, the pressure we're sitting in is 0 pressure. It's really not, but it's our starting point because that's where things are when nothing is being either pulled out or shoved in for pressure. Well, it's on about 14.5 if we're at sea level, right? That's why they say about 15. So if you're adding psi-G, you're going to have this, the absolute pressure is going to be about 15 plus whatever you're adding. That makes sense? You get what I'm saying? So
That's going to represent
it's representative of where just what you're feeling right now is psi-G. I mean, you're going to see that, and I want you to burn that in because everybody is going to see that sooner or later, and you see psi-G, you're going to say, what in the world are they talking about?
PSIG is, I've already forgot.
psi-G is what you're feeling right now.
Okay, PSIG is what
If you add pressure to that, then that'll be the psi-G reading.
Okay. How do
See, like if you added 10 pounds to that,
That'd be the PSIG.
that would be 25 psi-G. But if you subtract, in other words, if you subtracted 15 from your psi-G, you'd come back to your 0 pressure.
Okay.
See what I'm saying?
I remember that.
Is that? I used to see that a long time ago, and I didn't know what in the world they was talking about. I used to be so confused by stuff like that. But when you're in a class, and this is really something, when you're in a class with a bunch of other mechanics, and when I went to that General Motors school back in the early 80s, and that woman instructor was in there, she was good. She knew a lot of stuff. She would ask a question. There was 12 mechanics in that room. They're all professional technicians, but nobody wanted to answer any of her questions because they're afraid they'd get it wrong and would look silly. And she would say, what did you guys generally do when you heard an engine labor knocking? And everybody was sitting here. And she was intimidating, And I said, I don't know what these other guys did, but I just retarded the timing a little bit. She said, that's exactly right. And that's what the police did. Well, the other guys, they knew the answer, but they were scared that they would say something and she would call them wrong and they'd feel dumb because, she was sharp as a tack, And I think she still teaches down there somewhere. Her name's Ellen Smith. You know, she was a good teacher. Two technicians are discussing, well, excuse me, which of the following is not a CFC or HFCFC?
C.
CFCs are
Now,
chlorofluorocarbons.
how many of you can spell the chemical word that describes R12?
I can spell CFCs.
Yeah.
I learned that in environmental science.
Well, that's, yeah, they're hammering on that. Huh?
Kill not for this man.
R134A. Now, why were they worried about fluorocarbons?
What was the answer?
CFCs, they attach
I'm
to,
going to see.
Ozone.
yeah, they attach to the oxygen molecules in the ozone or something like that.
What is ozone?
Ozone
O3?
is O3.
O3, and where does it come from?
What does ozone mean?
Huh? Where does it come from? Where is new ozone made? Do you ever make any new ozone?
No,
Every time lightning strikes, you get ozone.
I know that.
Yeah. You ever watch the little lightning strike weather map? Bam, 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 bam. There's lightning striking all the time. It's always making ozone. Well, now the ozone layer is closing up. Not a big deal. That's like keeps, you know, radiation from sun from hitting us and all that kind of stuff. Okay, so what were they using to measure that? One of the things they were using to measure was the space shuttle. And when the space shuttle goes up, it puts out 17 tons of chlorine. And chlorine eats ozone. What's wrong with this picture? They must not have been too worried about it. Right? Well, I mean, the EPA wasn't going to say nothing about the space shuttle, I don't get. Okay, 134A is the one that's not a chlorofluorocarbon or a hydrochlorofluorocarbon. Now, R12 is the chlorodifluoromethane. That was the original name for it. Okay, so two technicians are discussing heat. Technician A says the heat always travels from hot to cold. This is a question from the last test. Heat's a form of energy. What you got? Both of them. R12 is normally used with what kind of oil? POE, mineral, PAG, or any of these? Actually, it's used with mineral oil.
Mineral. I see tag. I saw that somewhere today.
That's actually
that
the,
oil that goes into the.
yeah.
Question while I'm thinking about it, if they're used R134 because it wasn't a CFC or an HCFC, then what was their main advantage on that new one they're wanting to move to?
They're worried about what they do is they measure the R134A and they say it has a GWP that is higher than they're comfortable with. It's a global warming potential. Now the fact remains that 1234, that new refrigerant, doesn't work as good as 134, but they're wanting to go to it anyway. With the 1234 systems, it requires an additional heat exchanger in between. The heat exchanger would be like the evaporator or the condenser, but it requires an additional heat exchanger between the evaporator and the condenser for what 1234A to work right, or 1234YF. So it's not as good a refrigerant, but the global warming potential, they say, is less. Now they're basically launched into all of that to make sure that we would have some refrigerant we would have to pay $100 a pound for.
So it's
Brilliant.
basically hot water.
Yes, absolutely. You know, and Honeywell and I think DuPont make that refrigerant. Other people can make it, but you can't get a license to use it unless you get it from Honeywell or DuPont. So anyway, and the German car maker Daimler and Volkswagen said they weren't going to use 1234 because they said it's flammable and they don't want anybody getting burned alive if they have a crash. I don't know if it's really all that flammable. 134A is flammable too, but they're going to try to go with so the refrigerant they're going to go with in Europe, or they're wanting to go with, is the I think it's R744, which is actually pretty much CO2. How many of you guys ever play paintball? When you play paintball, the can that's propelling your paintballs gets really cold. Well, that seems like, well, why couldn't we use that for a refrigerant? Well, we can, but we got to have like 2,000 pounds of head pressure on the high side, and that's it's hard to contain that. All right, so let's see. An atom consists of all the following except molecules. That's right, because atoms form molecules. Number 17, compressing a vapor. What does it do? What does compressing a vapor do? Increases the pressure and the temperature. 18. When heating a substance, latent heat is what? That's the heat added to cause the change of state while the temperature stays the same. You remember what I told you? When you put a torch under a pan of water and you get it to 212, it starts to boil. The temperature of the steam and the temperature of the water are the same. Even though you're boiling the water,
What about temperature of the flame?
temperature of the flame is not even in play here. But the temperature of the steam is 212, temperature of the water is 212. The state has changed, but the temperatures remain the same. Got it? All right. All of the following are true of atmospheric pressure except what? At high altitudes, water boils at a lower temperature than at sea level. That's the first one. Is that one right? Based on what I told you earlier, it is, isn't it? B. The atmospheric pressure at sea level is 21.2 psi.
No.
That's a flag. It's 14.5. And finally, 20. Technician A says atmospheric pressure at sea level is 14.7. Technician B says atmospheric pressure is constant regardless of altitude. That's A only. All right. Okay. That concludes heat and AC.